Refreshing all your memory. So here we go. You ready? We're going to be getting nuts. Okay, here we go.
I like talking and chatting. Better than that.
So let's review. Pythagorean theorem. First, what is it? Very good. When do you use it? What about right triangles? When you're missing a side, use Pythagorean theorem in the right triangle. That's when you use Pythagorean theorem. What does SOHCAHTOA stand for?
Sine opposite over hypotenuse cosine.
We just kind of lost it now.
And when do you use SOHCAHTOA?
Whenever you're trying to find one side.
You're trying to find one side, you have the angle measure, or when you're trying to find an angle measure, you have two sides. You use this also with what types of triangles?
Right.
Right triangles. Now, when you're looking for an angle, you have to remember to use what? Whenever you're looking for the angle.
Negative. Oh, the inverse.
The inverse. That's -1. That's when you press the second button and then you press sine or cosine or tangent. Okay? The unit circle. We kind of talked about that already. Okay? With the unit circle. Right? Okay? I was about to print out a blank unit circle. See how much y'all remember? Yeah, do that. Okay, pop quiz and see. But you didn't need to know it for circular functions. You definitely need to know it for circular functions. Okay? Real quick. Quick review. What quadrant is tangent positive? First and third. Because tangent is what over what? Sine over cosine. And sine is your y. And cosine is x. Okay. What is the radian measure? What is the radian measure for 315 degrees? 7 pi over
11,
So 315 degrees is 7 pi over 4 because 315 degrees is located in your what quadrant? Fourth quadrant in the middle. Okay. Make sure you stay in your circle. Compass points. You guys remember compass points?
North. I remember going over it.
You got. How about this? What are your compass settings? What are your directions for compass?
North.
North, south, east, west. Okay.
North, south, east. Yeah.
All right. So you got north, south, east, and west.
This is like review.
So northwest.
Okay.
It's up and left.
So yes, compass points. You got north, south, east, and west. Never eat soggy waffles. I think that's one y'all use. Okay. Soggy waffles. Sour worms.
Sour watermelon.
Okay. And just a reminder. North, 20 degrees east. Okay. If they give you that, you come from the north direction and you head which way? So the left direction.
To the east.
To the east.
20 degrees to the east direction, okay? And if they said south, 40 degrees west.
Were they saying north, 20 degrees south?
So you start at south and then go 40 degrees to the west.
West.
I know you've heard of north. I know you've heard of east, but what about north and west?
Okay, so just remember that, okay? It'll basically tell you your directions. And now your compass bearings are based off of kind of like your compass points. But remember, you have 0, 30 degrees. You always start
East.
You always start from the north, and you always go clockwise for your compass bearings. Okay, so 30 degrees north, or 30 degrees would be going this direction for 30 degrees. and then let's say you had 225 degrees as your bearing. Say you had a bearing, okay? You're not going from your x-axis using your unit circle. You start from the north direction and you go 225 degrees as a bearing, okay? So it's like you are in your ship and you turn your ship and you head that direction.
Can you do it?
You know what negative? Airplanes, yep. Airplanes, yes. Not so much. They would just say the bearing with a positive degree. Questions on those?
These are usually word problems.
Yes, those were mostly used for word problems, okay? Let's see. Sine rule. You don't have to memorize it. It's in your reference booklet, but when do you use it?
When you have, side angle. No, that's cosine rule.
When you have one.
Yeah.
When you have two,
To find the missing.
Hey, let me check.
What do you want?
Is it when you have two sides?
An angle.
Or
Two sides.
one angle. Or
Two corresponding.
So you're saying that if I had 40 degrees and 80 degrees, you said two sides and the angle included?
I think that's cosine rule.
It's either.
Very nice.
No, sine is when you have.
Sine is when you have
two
two
sides.
different triangles and then you're trying to compare them, right?
Looks like we're a little rusty here. Okay? Sine rule. Sine rule is basically
Two sides.
One side too.
or vice versa. You know the signs could be on top, like basically this could be flip
Yeah.
fractions. Don't forget about that. Okay? So basically you either would have to know two angles and the side opposite of one of those angles. So say if I knew that this was 5, I could use sine rule. Okay? Or if I'm given two sides and an angle opposite of one of those sides, I can use sine rule here.
Top is cosine or sine?
So
Both of them are sine rule. So let's do. So for the bottom one, it would be 4 over sine of 70 equals 3 over the sine of the angle we don't know.
That's when you use the sine inverse.
It's really important angle. What about cosine rule? When do you use that?
When you have two sides
Two sides.
and two angles.
Two sides and one angle in the middle.
Find one.
Two sides and one angle in the middle.
Find those third.
Because then you use the final third side. Or
Three sides.
3 sides. Okay? Now with the sine rule, you got to remember about your ambiguous case. Remember, that's when you could have no triangles, one triangle, or two triangles. Don't forget about your ambiguous case. You always check for the ambiguous case when you have an angle side situation. Okay, that's when you always check for the ambiguous case, okay? So let's review the ambiguous case real fast.
That's when you have what?
When you have two triangles,
Two
they
angles.
could have the same proportions for
Okay,
those
no, like
particular sides that are given.
So remember with the ambiguous case, okay, it's always for that. What is it? Angle side or side? Angle side.
Side angle.
Yep, side angle. Sorry, side angles when you check for ambiguous case. So example like this, okay? So remember, the first thing you do is you would find that missing angle first using the triangle that they give you. Let's work this one out. Y'all ready? Everyone got this triangle down? And then I'll go through the steps, but I want to change slides so I can get a little more space.
No.
So find the missing angle. That's the first thing you need to do. Yes, you do need your calculator today. If you don't have it,
Really?
Small, but it's.
Alright,
I didn't think of it.
so we need to first find, let's label this A, B, C. Alright, so remember for these, we would set it up, we would need to find angle what?
B,
We need to find angle A first, so it would be 4 over the sine of 70 equals 3 over the sine of A. We would then cross multiply 4 sine A equals 3 sine 70. Divide both sides by 4. And then
Inverse.
take the inverse of sine.
yeah. Make sure you're in degrees, because we've been using radians.
I was about to say, yep, make sure you're in degree. Alright, what you guys get?
At 44.
44.8? Alright, so that's the first thing you do, okay? And it's at this point that you would check for the ambiguous case, okay? So remember, to check for the ambiguous case, you take the angle that you just found and you, so this is step 2, you subtract it from 180. Okay? So what's 180 minus, so that'd be 135.2. This is the potential second angle A, okay? This is the potential second angle A. C is still 70, side C is still 4, and side A is still 3, okay? Now the thing is, once you figure out that second potential angle, your last step would be to find the third angle. If it's positive, you have 2 triangles. If it's negative, you only have the one. And that's the one that you originally started with. So what's the third angle in this problem? What's B prime? How do I find B prime? It's a negative. Like a negative 5.2? 25.2. I cannot have a negative angle here, so there is no second triangle. It's only the one triangle from the beginning.
What if it's positive, but it's like
If it's positive, it's 0.2, then it's still a second triangle.
so you write
So you basically would have two sets of answers. 2 angle A's, 2 angle B's, and 2 side B's.
So negative.
Then there isn't one. There's only be 2. 2, 1, or 0. Now you'll know it'll be 0 triangles if at the very beginning when you found that first angle, it was an error message or something. Then you would know there would be no triangles that would fit the original specification.
And you put no solution.
So then it'd be no solutions or no triangles. And then, so since it's only the one triangle, we would finish this off. What's angle B? Some good practice here. Angle B is 65.2. And then we use what to find angle B? I mean, not angle B, side B. I can use sine rule or cosine rule. When you use the rules, try to use that long decimal. How do you transfer the long decimal down? Second minus transfers that long decimal down, okay? So I would set it up as B
Or
over,
it would be 5.
Technically,
it's not a right triangle though. I know, I did the same thing.
That's fine, yeah.
so find side B. I want everyone to find side B, please. So our answer here is yes, 3.86. So I'll do a little review of cosine rule. there. I mean, not cosine rule, sine rule, sorry.
I know this is so hard.
Cosine rule doesn't have any special cases, okay? Cosine rule is just, you know, pretty much simple. If you have side angle side or side side side, that's when you use cosine rule. Let's do a cosine rule practice real quick, okay? And if you don't remember, you might want to pull out your reference booklets.
See. It's square equals. Oh, that's
There, A, B, C. Solve the triangle. Solve the triangle. Yep, that means find every missing piece. Alright, so you do know there's the alternative form to figure out these angles, right? You could use that. And remember, you take one side, you square it, you add it to another side, and you square it, and you always subtract a side, square it, and it's 2 times 2 sides. Now, the side that you subtract is always the side opposite of the angle that you're trying to find. So I should have subtracted 6.56 if I'm looking for angle A, and then the other 2 angles should have been added and squared. Okay, this is if I wanted to find angle A first, okay? So then I will type this in, and I will get a number, and my calculator's down, I'm not gonna wait for it to load, so. Alright, so you should have gotten about 0.6438 and some change. You take the inverse, and A is about 49.9 degrees, rounding to 3 significant figures. And that's angle A. Okay. Huh?
3.63 is C.
Yep.
Yeah.
I just missed
Just remember, whatever angle you are trying to find, you always subtract the side opposite of it. Okay? So then, alright, here we go. So I'm going to find B next, so I'm just going to go in order.
I did not get it.
Like that. So check your numbers. I'm going to take 3.63 and I'm going to square it. I'm going to add the 6.56 and I'm going to square it. I'm subtracting the side opposite of the angle I'm looking for. That's how you should have set up to find angle B. Okay? So I do that in my calculator. So for cosine B, I got negative 0.2592 and some change. So when I take the inverse B, it's about, bless you, 105. So I'm rounding to 3 significant figures. Now honestly, I could have done sine rule after I found that one angle, but I'm just practicing cosine rule here. Lastly, there's 180 degrees in a triangle. So I'm going to subtract those 2 angles to get an answer for angle C, which is 25.1. And those should have been your 3 angles. Alright, last little bit. Area of the triangle. Formula given to you in your reference booklet. It is 1/2 AB sine C, and technically, it really is just 1/2 the 2 angles they give you, I mean the 2 sides they give you, and the sine of the angle in between. Okay? So even if they gave you these 2 sides and told you that this was 60 degrees, it would be 1/2, not AB sine C, but B, C, sine A. Okay? It just works the same way. You can only use an area of a triangle with side angle side. Alright? Lastly, radians, arcs, and sectors. Since you have your reference booklets on you, can somebody confirm that the area for a sector is in your reference booklet?
Yes.
Where is it?
What about,
It's on top of the first little box of circular function.
What about arc length?
Yes.
Okay. What about, how do you convert between radians and degrees?
Radians to degrees.
Pi over 180 is to go from what to what? That's right, degrees to radians, and
Whatever pi.
180 over pi to go to, from radian to degree, okay? Just in case they give you a problem and they want it to be in degrees instead of radians, but they give you radians to start with or something.
So does that work with the
And that works with the unit circle too. Say you knew what the degrees were, but you couldn't remember your radians, alright? Take I don't know, 240. If I multiply that by pi over 180, I'll get my radians. That's 240 over 180. The zeros cancel out. 24 and 18 reduce down to be 4 over 3. And that's what it is.